Okay, we're starting logarithmic functions for Chapter 4, Section 4, and it will continue for 4.5 and 4.6. You already had this in Algebra 2, and we already did some handout problems. So basically, a logarithm is merely a certain name for an exponent, and they're inverses of exponents, especially when you're graphing. So I'm going to do some problems here, and basically we're going to change. This is page, let's see, page, page 296 through 97, and I'm going to try to do all the way to 44, 9 through 44 odds. So that would mean this is not 44, this is really what? 43. And again, we already did a lot of these in class. The first thing you have to remember is that when you have a base times the power equals some value, we'll call it n, the equivalent expression is log of the base of the n of the number equals your power. So we're just writing it in two different ways, and we're going to go back and forth. So the first one, we're going to go from exponential to logarithms, and we have number 9, and number 9 is 9 equals to 3 squared. So basically this is your base, this is your power, and this is your value. And so we're going to change it to the log base n, log base of n equals your power. So this is going to be log, your base is 3, your value is 9, and your power equals 2. Okay, that's all we're doing. Now let's do some more. I'm going to flip it. I don't like how they have it. Okay, I'm going to flip it like they have it here. 11. They have a squared equals 1.6. So I'm going to change this. This is your base to some power equals n. And so we're going to change this to a log base of the number equals the power. So you're going to write log, your base is a, your power is your number is 1.6, and your power is 2. And that's all we're doing. 13 is 1.12 equals m. So that's going to go to log of your base, which is 1.1, of your value is m, equals your power is 2. And 15, we have 2 to the x equals 7.2. So that gets changed to log. Your base is 2, your number is 7.2, and your power is x. 17 is x to the square root of 2 equals pi. We just have to rewrite it. It looks weird, but just rewrite it. Your base is x, your value, your number is p, and your power is root 2. Okay, 19, we have e to the x equals 8. We're just rewriting. So log base e of 8 equals x. 21. Now, 21 we're switching. They give you this side, they give you the log, and we have to convert it to this. So 21 is log base 2 of 8 equals 3. And we're going to change it to exponential equation, which is 2 cubed equals 8. Makes sense. 23 log base 8 of 3 equals 6. So my base is 8. And this was A. Looks like an 8. So my base is A to the 6th equals 3. 25 log base 3 of 2 equals x. So 3 to the x equals 2. 27 log base 2 of m equals 1.3. You can stop me whenever you get this. So 2 to the 1.3 equals m. And 20, let's go to another page here. 29 log base root 2. I don't know how they wrote this. This is weird how they did it in the book. Let's just assume it's this. So our base is root 2 to the x equals pi. And 31, we have the natural log, and we haven't talked about that. The natural log is just basically, let's talk about it since I have it here. We have natural log of 4, or ln, some teachers call it, equal x. So basically what this means is, what you can do is you can write this as 4 equals e to the x. Okay? And there's a formula for this, but let me show you really what's going on. You're going to write this natural log of e equals 1. So what you do here is you take natural log of 4 equals x, and what I'm going to do is multiply this by ln of e. Then I use my power property and put it here. So I have natural log of 4 equals natural log of e to the x. Since I have the same thing here, I get 4 equals e to the x. Okay. Now, that's interesting. So we need to find the exact value of each logarithm without using a calculator. So basically, just remember that natural log of e equals 1, and I think we can get through this because we haven't talked about that one yet. So we're going to start with 33. They want you to evaluate without using a calculator. Now, occasionally I have seen this on a PSAT test. So we have log base 2 of 1, and they want you to evaluate that. And all you're going to do is go ahead and set this, until you get used to seeing this, go ahead and set this to your power, and let's rewrite this. So we're going to write 2 to some power equals 1. So what would p equal? Yes, 0, because anything to the 0 power equals 1. So until you get used to this, the best thing to do is set it to p. So here we have log base 5 of 25. They want to evaluate that. So basically, what are they looking for? They're looking for the power. Okay? So the power, we're going to rewrite it, and that's going to be 5 to some power equals 25. So that means p equals 2. So these are your answers here. Now what you can do once you get used to this, and you don't have to keep setting it to p, what I tend to do is just look at it this way. When you're trying to evaluate, just know that 2 to the 0 equals 1. 5 squared equals what? 25. So if you want to look at it that way, you can. Let's do some more. 37 is log base 1/2 of 16. Really I can't tell what this is. So what I'm going to do is set this to p and rewrite it. So I have 1/2 to some p equals 16. Now, you know what, if it was 2 to the p equals 16, what would p equal? Right, p would be 4. But since it's a fraction, p is just going to be -4. Because 1/2 to the -4 equals 16. All this means is, the negative means you flip it and take away the negative. So that's 1/2. We're going to flip it. So that's 2 to the 4th. So we're back to here. So when you see this fraction and a whole number here, you're going to have to do the negative. So our answer is -4. P equals -4. Alright. 38. Here's another one of those. Or 37. 36, I mean. I can do 38 if you want. Let's do 38, because that's the same thing. Let's look at that one. So we have log of 1/3 base 1/3 of 9. Now we're going to set this to p. So we have 1/3 to some power equals 9. Well, you know, if it was just 3p equals 9, that p would be 2. But since this is a fraction, we're going to just let p equal -2. Because the 1/3 to the -2 is equivalent to writing it that is 3 squared. Or 3 over 1. And that equals 9. Okay, let's do 39. It looks interesting. 39. Log base 10 of root 10. I'm not sure. So what I'm going to do is set this to p and see what happens. So I have 10 to some power equals root 10. Well, still looks kind of confusing. So what I'm going to do is write my radical form into exponential form, to rational. So this is radical way of writing it. This is the exponential way of writing it. You learn that in Algebra 2 as well. So now I have equals 10 to the what? 1/2. So clearly, p is what? 1/2. Okay. Now let's do 41. That looks interesting as well. I like the interesting ones. Log base root 2 of 4. I'm still not sure. So I'm going to set this to p and do it the long way. So I know I have root 2 to some power equals 4. Well, what we learned from section 4.3 is I'm going to change these to the same base. I already know that this 2 from the last problem, I can write that as 2 to the 1/2. Right? That's the square root, so it's a p. And I'm going to change this base to 2 squared. So this is really 2 to the 1/2 p equals 2 squared. Now I'm going to just deal with the numerator, or the exponents. So 1/2 p equals 2. Multiply both sides by 2 and I get p equals 4. Okay? So that's your solution set. Yeah, I like that one. And 43. Whoops. So 43. I have natural log the square root of e. I believe this one's on your review. Now, what I told you earlier is natural log of e equals 1. We also went over some of the properties of logs on our handouts. So what I'm going to do is rewrite this as natural log of e to the 1/2. Again, changing the radical form. This is the radical way to write it. And this is the rational way to write it. Now I'm going to use my power property and pull this in front here. So this is 1/2 natural log of e. We also know natural log of e equals 1. So I have 1/2 times 1, which equals 1/2. So it basically just equals your power. Okay? And I'm going to try to find in the formula in the book. Basically, the formula in the book is this. If you just want to go by the formula instead of what I did. Y equals natural log of x if and only if. If and only if. You have Dr. Tish, she probably taught you this. If and only if x equals e to the x. E to the y, sorry. So that's basically the formula they're using for that. And that is all for that section. The next thing we're going to be doing is, for the next video, is finding the domain, and then we're going to look at some graphs. Okay?